In this video, I introduce combining VAE and Transformer for zero-shot text-to-image generation. A discrete variational autoencoder is applied to train a transformer to autoregressively model the text and image tokens as a single stream of data with zero shot, which reduces the memory requirement by modeling the image patches as a discrete visual tokens. The image generation model consists of a discrete VAE and a transformer. The discrete VAE learns a discrete vision representation of images and then converts the sequence of tokens back to an image. Transformer autoregressively generates images using as input a sequence of tokenized image caption and tokenized image patches as shown here. The discrete VAE further compresses a 256 by 256 RGB image into a 32 by 32 grid of image tokens as shown here. And each token has 1,192 possible values, which reduces the contact size of the transformer by a factor 192 as shown here. 256 byte pair encoding text tokens with the 32 by 32 image tokens train an autoregressive transformer to model the joint distribution over the text and image tokens. The generative model training is performed by maximizing the evidence lower band on the joint likelihood of the model distribution over image X, caption Y, and the tokens Z for the encoded RGB image. The joint likelihood is modeled by using this formulation, which results the evidence lower band as shown here, where Q5 denotes the distribution over the 32 by 32 image tokens generated by the discrete VAE encoder given RGB image X as shown here. P theta denotes the distribution over the RGB images generated by the discrete VAE decoder given image tokens as shown here. And P psi denotes the joint distribution over the text and image tokens modeled by the transformer as shown here. The model training consists of two stages. The first stage maximizes evidence lower band with respect to phi and theta to train the discrete VAE on the images all along. The initial prior P psi is set to the uniform categorical distribution over key codebook vectors and Q phi to be categorical distributions parameterized by the key logits at the same position in the 32 by 32 grid output by the encoder, as shown here. This input image, this image tokens, and this decoder, this transformer. Since Q phi is a discrete distribution, as shown here, it's hard to perform backpropagation through the discrete VAE encoder. The combo softmax relaxation replaces the expectation over Q phi with 1 over Q phi tau. That is a continuous distribution, but samples are discrete. Where the relaxation becomes tight as the temperature tau tends to 0. The likelihood for P theta is evaluated using the log Laplace distribution. Fixing phi and theta, the second stage learns the prior distribution P psi over the text and image tokens by maximizing the evidence lower band with respect to psi. where psi is represented by a sparse transformer. Given a text image pair, the locus the caption is byte pair encoding using at most 256 tokens with vocabulary size 16,384. And the image is encoded using 1,024 tokens with vocabulary size 8,192. The image tokens are obtained using argmax sampling from the discrete VAE encoder logics without adding any common noise. Finally, the text and image tokens are concatenated and modeled autoregressively as a single stream of data. Here is some samples from the model. This is the model generations, this validation, and this corresponding captions. For more details, please check with these references. Thank you. Bye.